So here we go with lesson 9. Now we're going to look at some real algebra, some equation solving strategies where we're going to be using all the tools that we've learned so far. So what we're doing is expanding out any of the brackets. Remembering that we're going to use the distributive property. So we've already looked at the distributive property, and that's how we're going to properly get rid of the brackets. We're going to collect any like terms with x or y or a or b, otherwise known as the variables. We're going to get all the variables that we're interested in on one side of the equation. And we're going to keep the constant terms on the other. So for the problems that we're going to be doing right now, we're only going to be looking at one variable. So it's easy to say we keep the variable on one side and all the constants on the other. Eventually, we're going to get a little more complicated, and we're going to get to the point where we have multiple variables in use, and then we're going to focus in only on the one that we're interested in. But for today's lesson, we're going to keep it simple. We're only going to have one variable total. So let's take a look at that first example and see if we can work our way through it. So the very first thing we wanted to do was expand out the brackets. So we're going to use the distributive property, and we're going to expand out the brackets. So this is going to end up being 4 times x is 4x. 4 times positive 6 is plus 24. Oh, I have my equal sign the wrong spot. Force of habit. My equal sign goes in the middle. 3 times 9 is 27. And then 3 times positive x is positive 3x. Notice there's only one equal sign on that line. You can't have more than one equal sign on a line in order to have proper mathematical notation. So let's work it out. We need to get all the x's on one side. So we're going to use inverse operations. So we're going to look first at that 3x. I'm going to move it over to this side, and it's an addition question, so it's going to become a subtraction question. So I'm going to have 4x minus 3x plus 24 equals 27. Now I need to get rid of the plus 24. So I'm going to move it across. It's an addition question. It's going to become subtraction. I'm going to get 4x minus 3x equals 27 minus 24. Now, a lot of times, you'll see people combining those two steps in one. And I really don't mind combining those two steps in one as long as you're making sure you get the sign conversions correct, or the operation conversions correct. Because it can be confusing if you're trying to do more than one thing at once. So if you're just learning this technique, it's better to do each one separately until you get really comfortable with it. So now we're going to use the collecting like terms, which is already done for us, and we're going to say 4x minus 3x. So if I had 4 apples and I take away 3 apples, I'm going to have 1 apple, which I'm just going to write as x. 27 minus 24 is 3. I've solved the problem. X equals 3. Let's look at the next one. Again, we need to do some expanding of brackets. So I've got 4 times 2, 8a. 4 times negative 7 is negative 28. Now here's an interesting one. Remember, when we have a negative in front of the brackets, we have to treat it as if it's negative 1. We have to expand the bracket with the distributive property anyway. So negative times the 2a is minus 2a. Negative times negative 7 is going to be positive 7. Okay, then my equal sign. Then we're going to expand the 3. 3 times 4a is 12a. 3 times negative 8 is negative 24. Now all the brackets are gone. Now we can start rearranging. Oftentimes, students want to skip to the rearranging part. They figure they can expand the brackets in their head. And what often happens is you miss that negative. You miss this one here, and you don't have the correct negative and positive signs on some of your numbers, some of your terms, which means that you're not going to get the correct answer. So let's look at which ones need to be moved. So I'm going to take the 12a, and it's going to come across. It's plus 12a. It's a positive number, so it's going to become a subtraction. I'm going to get 8a minus 28 minus 2a minus 12a plus 7 equals minus 24. Now remember, that negative 24 didn't change, so it stays negative 24 on the other side. And what do I need to move over? So I've got this negative 28, and I've got this positive 7. So let's see if we can move them both. All right. Negative 28 is going to become plus 7 is going to become minus. So I'm going to get 8a minus 2a minus 12a equals minus 24 plus 28 minus 7. So I've got 3 terms on each side. Now I'm going to simplify. 8 minus 2 is 6. 6 minus 12 is minus 6a. Minus 24 plus 28 is going to be positive 4. Positive 4 minus 7 is negative 3. So now I'm not done yet. I still have, so I'm going to move this over just a bit. I'm going to bring my answer up here. Continue solving on the side. I still have this negative 6a equals minus 3. So what kind of operation is this negative 6a right there? Well, that's a multiplication. That's negative 6 times a. So I'm going to divide. I'm going to have negative 6a equals negative 3. I'm going to divide by negative 6. Negative 6. I'm going to do that to both sides. I have to do that to both sides. Negative 6 divided by negative 6 equals 1. And negative 3 divided by negative 6 equals 1 over 2. So my answer is A, because the same as 1a is just written as A equals 1 over 2. Okay, a lot of times people are going to answer A equals 2, because in their head, 6 divided by 3 is 2, 3 divided by 6 is, they're just not going to recognize that that's the wrong way around. So make sure that you're paying especially close attention to the negative 3 over negative 6 as opposed to 6 over 3. So we've got a couple more examples here, just practice. Okay. So in this case, we have some fractions. Now, how am I going to get rid of the fractions? What's a really good method for getting rid of the fractions? So I'm going to show you a really easy way to deal with fractions all the time in any kind of algebraic problem. And if you want to get rid of a fraction, you can multiply by the denominator. But remember, if you multiply the fraction by the denominator, you have to multiply everything else by the denominator. And in the case where you have multiple fractions, you can multiply by the lowest common denominator, and then it just goes away and becomes a regular problem. So I'm going to put a little star here in red, and I'm going to say multiply by the lowest common multiple of the denominators. Minators! Exclamation. And watch how this works. Let's switch back to green. Okay, the LCM here is 6 because the denominators are 2 and 3, so the lowest common multiple is 6. So I'm going to multiply everything by 6. So I'm going to have 6 times x over 2 plus 6 times x over 3 equals 6 times 10. Note, the 6 multiplies everything. It's really, really important. So 6 divided by 2 gives me 3 times x, plus 6 divided by 3 gives me 2 times x, and then 6 times 10 is 60. So what I end up getting is 3x plus 2x equals 60. 3x plus 2x equals 5x equals 60. And now I'm going to divide both sides by 5 and get x equals, what is 60 divided by 5? 12. Now, if you think that seems too easy, let me demonstrate to you that this has worked. So I'm going to go back to green. And I'm going to plug my number back into the original. So if the original is x over 2 plus x over 3 equals 10, I'm going to put 12 in there. So I'm going to say 12 over 2 plus 12 over 3 equals 10. And I'm going to do that magical thing called a left side, right side check. So this is my left side, this is my right side. So I'm going to solve them both independently. So the right side's going to stay 10. 12 over 2 is 6. 12 over 3 is 4. That's 10 as required. Remember I said the left side, right side check is a formal proof that you can use to check your answer for any algebraic problem. And here you go, I've just used it in this context. So I'm going to say, here is your left side, right side check. Let's try this one more time. What's my LCM? The LCM of 4 and 6 is going to be 12. So I'm going to multiply everything by 12. So I'm going to say 12 times x minus 1 all over 4 plus 12 times x minus 3 all over 6 equals 12 times 3. So once again, every term in the equation has been multiplied by 12. Very important. So now I get my cancellation. 12 divided by 4 is 3, 12 divided by 6 is 2, and I get 3 times x minus 1 plus 2 times x minus 3 equals, what's 12 times 3? 12 times 3 is 36. And now it's just a regular problem. I can solve it like I've been solving everything else. So I'm going to go through this really quickly for you. So 3x minus 3 plus 2x minus 6 equals 36. So I'm going to have 3x plus 2x equals 36. I'm moving the minus 3 over. It's going to become plus 3. I'm moving the minus 6 over. It's going to become plus 6. So I'm going to get 5x equals 36 plus 3 is 39. It's going to be 45. Divide both sides by 5. And 5 divided by 5 is, oopsies, sorry guys, keeps moving that around. 5 divided by 5 is 1. 45 divided by 5 is 9. I'm going to get x equals 9 as my final answer. So you can see using this lowest common multiple method is a really elegant and easy way of taking the fractions out of the equation.